In section 4.4, we're going to talk about triangles. And before we can talk about triangles, I want to make sure everybody understands angles, because it'll be hard to talk about triangles without understanding angles. So an angle is formed when two lines or parts of a line join at a point called the vertex. So we just have a line here and a line here, and they join at this vertex. So you have to understand the concept of an angle and understand what we mean when we talk about a vertex. So we also have some conventions for naming angles so that when we look at an angle, we don't have to point at it. We can use words or letters to tell you which angle we're talking about. And so what we do to do that is just stick a letter next to the vertex. And then, so this angle would be called angle A, as we put an A next to the vertex. So we do the same kind of thing when we're naming triangles. So this was angle A because the A was next to that vertex. Then we put a B here and a C here. And then the triangle becomes triangle ABC. So when you see this, you're reading triangle ABC, and you know it's a triangle with vertices A, B, and C. So one way we can describe an angle is to give its measure or size in degrees. So a complete circle is 360 degrees. So we're trying to indicate that with this. So we're saying it's an angle that's almost all the way opened up. We would have opened it all the way up, but then it would have looked like a line instead of an angle. So we're saying it's an angle that's all the way opened up is 360 degrees. This one doesn't look much like an angle, but this is the vertex right here. And if we take an angle and open it all the way up, it'll be 180 degrees. And this is one you're probably familiar with. Shows up a lot in the world. It's a 90-degree angle. So the concept here is that we can take our two lines and they can look like this, and that's a small angle, and then we can open them up a little more, and it becomes a bigger angle, and then we can open them up even more, and the size of the angle increases. So that's what we mean when we talk about the measure of an angle. And we tend to measure it in degrees, although in later math classes you'll measure it in different measures too. So one of the ways we measure angles physically, when we have an angle and we want to written on a piece of paper or on a welding project or anywhere building a roof, if we want to measure an angle, we're going to use a protractor. So you need to have a protractor for this work, and you need to know how to use it. So make sure you have one available to do this section. So here's an example of a protractor. Different protractors look different, but they all share some common aspects. And so one of them is the crosshairs right here. So the crosshairs is really this thing right here. And it's a crucial thing because that's where you're going to line angles up when you're measuring them. So again, different protractors have different looks to them. So some of the protractors, instead of having a real crosshairs, they have a little hole in it there, and so they have some lines approaching that hole, but the hole is there so you can look through it and place it right on the angle. So just make sure you know how to use the one you're using. So then the other thing you notice is that we have two different scales. So we have this scale here, and then we also have this scale out here. And if you notice those numbers, all add up to 180, 30 plus 150, 40 plus 140, 50 plus 130. That's not a coincidence. So the way this works is there are two different scales, because sometimes you'll have an angle that's lined up in one direction on the protractor, and sometimes an angle that's lined up in the other direction. And so you have to be really aware of which scale are you using. And so we're going to talk about that for a second. You'll see the difference between them. So if you've got an angle written on a piece of paper and you want to measure it, what you do is put your protractor over the top of it. And so remember I said before that we want to put the vertex at the crosshair. So that's the vertex of the angle, and it's lined up right on the crosshairs of the protractor. And then remember, an angle is made up of two lines. So we take one of the lines and we line it up at 0. Now notice we have two different zeros, so here's a 0 over here, and here's a 0 right here on our scale. But because this angle is pointing over in this direction, we're going to line it up with one of the lines against this 0. We're going to put this 0 here, and we're going to put the vertex on the crosshairs always. And then we're going to read up the other line. So we're going to read up here and see where that crosses the scale. Now, make sure you know which scale you're looking at. The way I know which scale I'm looking at is which 0 did I line it up with. See, I didn't line it up with this 0 over here. So I'm not going to use what on this protractor is the blue scale. I lined it up with the 0 on the black scale. So that means I'm going to read it from the black scale. So I'm looking along this scale here, and so I have 70, 80, here's 70, here's 80, here's 75. So that means this angle is going to be 76 degrees. So this thing of picking the right scale to use is probably the most confusing thing I've seen for students. A way to check yourself is if you were to use the wrong scale here, you would claim that this is a 104 degree angle because we're right here in between 100 and 110. And just remember that a 90 degree angle, you know what a 90 degree angle looks like. It's a right angle. And this angle is less than a 90 degree angle. And so if you read the wrong scale and you say that it's a 104 degree angle, you should be able to look at the angle and say, that doesn't make sense. I must have picked the wrong scale to read. So when you're measuring on the protractor, if a side of your angle lines up with 0 on the inner scale, read its measure from the inner scale, the inside scale. If the side measures up with the 0 on the outer scale, read from the outside scale. And we'll practice these when you do these in class, so you'll get lots of practice doing this. So how do we measure an angle like this that's not only over on the other scale, but it's short enough that I can't see exactly where it's hitting out here, and I don't want to estimate because you might be quite a ways away from the scale, and not all of your protractors will have this. If you look at this one, it actually has the scale lines extended down in here, but a lot of protractors won't have that. So what we're going to do to measure an angle like that is first we're going to do the same things we've been talking about. We're going to line the angle, so we're trying to measure this angle here. So we line the vertex for that angle up with the crosshairs on the protractor. And then we line this line of the angle up along well, I just crossed it out, but there's a 0 right there on the inner scale. And so we line it up with that, and that means we know we're going to be reading off of this scale here, because that's the 0 I lined it up with. I lined it up with that inner scale 0. The outer scale reads 180 there, so I know that's not the scale I'm going to use. So then what I'm going to do is just take a ruler or the edge of my protractor and just extend that line out. Obviously I have to do that accurately if I want an accurate measure. Make sure it's a completely straight line. But then once I extend that line out, now I've got it all lined up. I've got the vertex and the crosshairs, this line along the edge of the protractor or along the 0. Sometimes that's not the edge of the protractor. And then I'm just going to read off of that scale. Now remember, you're using the inner scale because that's what 0 we lined it up with. And so I'm looking at this is actually 30, and up here is 50, because I'm reading off this inner scale. And so I go 30 here, 35, 36, 37, and so I get 38 degrees for that angle. So remember, if you read the wrong scale, you would claim that was a 142 degree angle, and you look at that angle, you know it's less than 90 degrees because you know what a 90 degree angle looks like, and you just realize, oh, I just read the wrong scale. I'm just going to go back and read the correct scale. So the next thing we're going to work on is triangles. So make sure you understand the material we just talked about angles, and then you'll be ready for the next video about triangles.